Yes, children. So we come to the end of the chapter. That is the last topic is left, and the last topic is DNA fingerprinting. DNA fingerprinting. What does DNA fingerprinting mean? It is not something new now. Some 15 years back, when 12, 13 years back, when this book was newly introduced, it was something, a new topic, which everyone was not aware of. But today, who is there who is not heard of DNA fingerprinting? Practically everyone has heard about DNA fingerprinting because it is practically every day it is in the news for so many different reasons. Whenever there is any crime, whenever there is any case like to find the parentage, or whenever there is a rape, or whenever there is any such thing where we want to know the person who committed that crime, we want to know and know for sure that he or she is the real person. Then we have only one option, that is called DNA fingerprinting. So DNA fingerprinting is a very precise method. There is no chances of any error in the DNA fingerprinting, unlike the fingerprinting. Fingerprinting is very common nowadays. You see every mobile has got fingerprinting app. So you enter in a mobile through fingerprint, you are transferring your money through fingerprint, you are doing so many different things through your fingerprint. But that fingerprint is actually depending on the lines which are there on your thumb or on your fingers. Each finger has got certain specific pattern of lines, and these patterns of lines are not found anywhere in the world with any second person similar to yours. And that is why the fingerprinting was used from the ages in order to detect the various types of crime. Suppose someone has entered in the room and he touched so many different things. So here the fingerprint marks are there, which may not be clearly visible to you. But when those people who are actually coming to pick the fingerprint, they bring a certain type of powder, they simply blow over it and the patterns are left, and these patterns are picked by them and they are matched with the already existing database which they have. And if there is no database, then they look that who must be the possible people, and their fingerprinting are taken and the fingerprinting are matched, and if it is matched, then the person is caught. But there are so many different loopholes in this. Suppose a person comes with a gloves on. Suppose someone has got some marks on his fingerprint. The fingerprints are not clear, and then the chances of the probing is sometimes lead to that is wrong. But DNA fingerprinting is very, very much accurate. Now, what is the basis of the DNA fingerprinting? DNA fingerprinting is based on the repeated units. Okay, repeated units which are found in the DNA, which are actually coding for nothing. Okay, they are not coding for anything. I'll just see that it may be written somewhere. That is called polymorphism. Okay, so it is based on the polymorphism and the comparison of the polymorphism. Okay, and okay, let us study some of it. In yesterday's class, when I was teaching human genome project, I said this is the DNA of the person. In the DNA of the person, some genes are there. As we studied in the first number of chromosomes, there are 2,968 genes are there. Okay, so there are so many genes present. The genes which are coding for a particular function may not have any variation among the various people. As we studied in yesterday's class only, that is 99.9% of the genes are exactly same. 99.9% of the genes are exactly same. So the variation which we see here is only in the 0.1%. So 0.1% people may show how much variation. Very, very rare variation are there. But the very rare variations are found where that I'll just enzyme. It is only for an example I am saying. So there will be no variation in this. So what is the there, that is if we compare the two people's DNA at these places or these places, there won't be any variation. Variation can found in the skin color, but that also there may be so many people who may have same kind of skin color, so their genes may be same. So we are not considering those pieces of the DNA which are standing as a gene. These pieces which are consisting of coding for a particular gene, we are not paying attention. Between these, there are some non-coding segments. They are called polymorphic genes or polymorphic segments. Polymorphic segments of the DNA, or in common we call them as VNTR, variable number tandem repeat. Variable number tandem repeats are those segments which differ in every person. There are no two persons which may have the exactly same type of VNR in the different places. Now I can't simply say so boldly that there are no two people may have same. In one place, two place, 5 places, 10 places, 100 places, they may be same between the parent and the offspring. Father and a son or a father and a daughter. They may, because we are receiving, suppose I got this chromosome and this chromosome from father. So among this I got from father and this one I got from mother. So whatever type of tandem repeats are there, whatever type of tandem repeats are there in the father and mother, that will obviously be there. But not always same. Why? Because there is another event called crossing over. So suppose this segment of the father and this segment of the mother are exchanged. So in that case what you will find that here these segments are same, these segments are same, but these segments of the father and mother may differ in the child. So suppose this is the father's chromosome, this will be here, this will be here, but the third one will be of mother, so there will be a variation. So even from the parent, the offspring they get variation in their tandem repeats. They are not exactly same. But by and large, there are a number of places they may be same. And that is why what we have to do is, when we are using chromosome for the DNA fingerprinting, we have to take different chromosomes. Okay, we cannot simply compare one segment and say that this is the person who is involved in the crime because his VNTR or the variable tandem are matching with the culprit's VNTR. Because one place, two places, it may be same, even in the non-related people. Okay, they may have same line of descent from so many generations, so these segments may come. Hence, what we have to do is, we have to take the segment from different people. So, two things I made clear that we have to take, that is the DNA has got several genes and there are several non-gene segments. The gene segments are made very often very same. But in between those segments which are called polymorphic segments or those which are called VNTR, that is variable number tandem repeats, they vary from person to person. Except in the line of descent, that is from the parents or grandparents or great-grandparents, they may come. But there again, there are variations, that is a certain segments of ours, one chromosome may be of father and the other segment may be of mother. So in the same chromosome, if we take the VNTR from the different places, we make it different from the parent. So we can easily find out that there is a difference between the father and the son, or father and a daughter, or mother and a son, and a mother and a daughter. So we can very much accurately catch the who the culprit. It can't be that the father, in place of father you got the son, or in place of father you got the mother, or in place of son you got mother or father, and like that. So VNTR is, that is these repeats. Now in the yesterday's lecture I said how VNTR are developed. In due course of time, when the chromosomes were copying, there are possibility of developing error. Now suppose these errors are developed in these genes, then the gene will also show some variation. In place of HCl, it will make something else, or it may not make any enzyme at all. So that such a person will not survive. So variation should gene or variation can come in a gene in such a way that it hardly affects. Like my skin color, what way it affects? Even a person is fair or even a person is black, what difference does it make in the total functioning of a person? It is only in the appearance the difference is. So functionally there is no difference. So such variation can survive. Such variation can survive. Yet we are not considering those genes. Maybe skin color gene, maybe blood group genes, maybe eye color gene, maybe hair shape gene, or maybe eyelashes gene and all. We are not considering those. Any segment which is standing as a gene, we are not considering it for the DNA fingerprinting. What we are considering for the DNA fingerprinting is the V and T R, that is those segments which are not coding for any gene. They are there unnecessarily. They are errors. They are caused because of the mutation in due course of time. And they are repeated hundreds to thousands of times. Several hundred to several thousands of times. Okay. So I think it is clear to you that what segments are we using for DNA fingerprinting. Unlike in the fingerprinting where we use only the finger, that is lines. Here we are not using the finger lines, but we are using the VNTR which are found in a chromosome. Suppose there is a crime. Suppose here some crime took place. From the crime side, we can get any one of these: a drop of blood, saliva, skin, hair follicle, or semen, or any other cell which has got its own nucleus. So suppose there is a fight took place between two people, so there will be a physical the struggle between them, and the nail mark may contain some of the cells. Suppose somebody entered in someone's house, and from there he took out a cup and poured some juice from the fridge and he drank. So some of the cells from the lips may stick to the glass or the finger. That is, whenever we touch anything, we are leaving finger mark. What does finger mark are? Actually, these are the protein layers which are coming out, the cell layers which are coming out, peeled off from our body. Every second, every time when we are touching, some of the cells from our skin loses, and that goes and sticks there. So there were cells. Whenever someone catches the hair, so there the cells are there. The semen, suppose in case of rape or in case of any other case, that some semen may be left there. So those are there. Saliva may contain some of the cells from the cheek and all. So any of these places where we get some cells. The sources of the cells I said, maybe blood, maybe saliva, maybe hair follicle, maybe skin, maybe semen, maybe anything else. These cells are taken. Then their cell membrane and nuclear membrane are dissolved and chromosomes are separated. Chromosomes are separated. Cell membrane, nuclear membrane, and the histone and non-histone protein which are found in the chromosomes are removed. Then ultimately we get only DNA. Now there are so many different DNAs, that is 46 chromosomes are there, 46 DNA will be there. Now you have to choose which chromosome you are choosing, which chromosome you are taking. Suppose this is the chromosome number 4, then another chromosome you take chromosome number 9, then another chromosome you take chromosome number 17. 3 chromosomes you are choosing. You can take more also if you want accuracy. Sometimes even in case of DNA fingerprinting, we see that the result is not accurate. Why it is not accurate? Because the laboratory may take only 1 or 2 segments. More the number of segments we are taking, more will be the possibilities of accuracy. So suppose this is our 4th segment of the and here it is 20%. 4 chromosomes we are taking. Why Human genome, we already know that which segments are gene and which one are non-genetic, that is polymorphic or VNTR. Suppose this is the VNTR. So this VNTR we are taking from here, this VNTR we are taking from here, this VNTR we are taking from here, and this VNTR we are taking from here. 4 VNTR, one from each chromosome is taken. Mark. Now what we have to do is, these chromosomes we have to take and we have to digest them from there using restriction enzyme. So the next step is the cut the V and T R segments using restriction enzyme. Restriction enzyme. Now what are restriction enzyme? Restriction enzyme are those enzymes which are cutting the DNA between a certain nitrogen bases. Okay, so we know that the gene, that we are, there is a gene, and what is the last nitrogen base of this gene? The next gene is starting. What is the first nitrogen base of this gene? Because the genic segments in nitrogen base will be not any variation contained. So there won't be any variation there. So those places we use them to cut. What we use it? This is called endonuclease, the restriction enzyme, or endonuclease, whatever you want to use. Now the segments have to be separated. So we have got a device called electrophoresis. In the electrophoresis, all the DNA segments are kept here. Now we know that the DNA are negatively charged, and here we have got anode. These are called well, and a charge is applied, and some gel is filled here, like agarose gel. So when the charge is given, the negatively charged DNA will move towards positively anode. So negatively charged DNA will move towards the positive anode. And during this, since the agarose gel is a dense substance, so it will offer resistance. So only the smaller segment will be left behind. Smaller segment will travel fast, the larger segment will left behind. So we must know that in which kind of segment are small segment and which kind of segments are large segment, and accordingly we will pick them. We must know that this segment is how long, this segment is what length and how. So according to their density gradient, they will move, and we have to we have a calculation that the smaller segment by this many time it should reach here, this many time it should reach here, this many time it should reach here. And then using a nitrocellulose film, we just pick them. Okay, so they are charged particle, and the film does any plastic film, you know, they are got charge, static charge. So similarly, nitrocellulose in the film, when it is touched to it, these DNA fragments stick to it, and then these segments are taken. Okay, so this is called separation of DNA. Okay, now separation of the VNTR from the DNA. Now what we have to do is we have to anneal them. The DNA segment which are still double stranded, we have to anneal them. So annealing is done by heating. Okay, so this is called annealing. Okay, after annealing, these DNA segments are exposed to the radioactive nitrogen nucleotides. Okay, we got the four. This is the first number, this is second number, this is third number, and this is the fourth number. VNTR we got the first VNTR, second VNTR, third VNTR, and fourth VNTR. And then they are exposed to the radioactive nucleotides. And according to the base pairing rule, adenine with thymine, cytosine with guanine, guanine with cytosine, thymine with adenine, they will hybridize. Now, whatever is the sequence here, that same sequence, same complementary nucleotides will arrange. Whatever sequence here, complementary nucleotide here. This is all there. And now they are passed to the autoradiographic machine. So we get the segment, the nitrogen base sequence of the unknown segment. So we got half of the work done. Now we got the 4 VNTRs nitrogen based sequence. I just made it 4, 5, 6, 7, 10, but they are in thousands. They are in thousands. Larger the better. Chances of error will be less. So they are in thousands. Now we got a sequence of unknown VNTR of the culprit whose cells were left there. Now what we have to do is we have to repeat the same process with the doubtful culprit whom we got doubt. We got doubt that so and so person or this modus operandi is done by so and so person. So we'll either we have got their blood samples or the gene segment there or nahi hai, so we will call them. Suppose a lady in a hospital says my child is exchanged. Very common crime in India. The girl child, the mother has got girl child, she will simply bribe someone and get the child exchange. So in place of girl, she may get a boy, and the boy will get a girl. Now the mother is saying, I gave birth to a boy and now I got a girl. The nurse has given me a girl, that means she has exchanged the child. And there will be some problem. Ultimately the case will go to the police station, and from police station it will go to the court, and court may ask them for the DNA fingerprinting. So now we got a child here on girl child, which this lady is saying is not mine. My child is with that person, yeah, that lady. Okay, now this girl child's DNA fragments are taken, and this girl child who is with a mother who is not her real mother. So what we have to do is we have to take her mother's and her father's chromosome, the same chromosome and their same DNA will be taken, and the same process will be repeated, and we get the DNA sequence, the nitrogen based sequence of the father and mother, and then we have to match it. If the daughter, this girl is of really of these parents, at least in 3-4 places we should match, and if it doesn't matches, that means the girl is not of these parents. Now either it will match to father or it will match to mother, because crossing over took place. Sometimes it may be possible that this much of segment of father and this much of segment of mother is there. So, and here in the case of this much of mother and this much of father, so here the mother segment is come, here the father segment is come. So some of the segment will match with father and some of the segment will match with mother. But whatever segment are there, they should match with any of these two, either to the father or to the mother. If it is not so, that means this girl child is not there. Now, who is supposed to be the offspring or the child of this family, that child's blood will be taken, and that will also be matched. And if that matches, the court will give its verdict. Since the DNA fingerprinting was not matching with this child and the parent, so this is not these are not the parent of this, and the other child is their actual son. Okay. Number of places we have used DNA fingerprinting to solve the cases. May it be parenthetic, may it be rape cases, may it be multiple rape, gang rape, what it is called. Number of people are raped a lady. Now, she may be brutally hurt and she may not be knowing that who were the culprits. But by looking their little bit face or by languages or by name, she tells these are the culprits. Now they will simply deny we were not there. Semen are there in the ladies, the girls or ladies' body. From there the semen will be collected and the same process is repeated. And wherever the semen's chromosomes DNA fingerprinting matches with the culprit's DNA fingerprinting, they are the real culprit, other will be saved. Okay, so this is how it is used for so many different type of cases. Sometimes property issues are there. Now suppose a child is left the home when he was in the childhood only, or when he was in the reached to that adolescence, because of the friction between the father and the son. He left out. Now when the father dies, the son comes and claims the property, and the father's relatives, they think since his son is not there, let us claim the property. So there will be two different people, the father's relatives and the father's son. There will be an issue. Now those people may say he is not his real child. He was an adopted child, or he was not a real child at all. So then he has to show his parentage, whether the died parent is of his or not. A bus is going and catches fire. Now one of the person had insurance of 10 crore rupees. The person's family claims that the so-and-so person who was going in the bus got fired and the body is brutally burnt, completely burnt. We cannot recognize the body, and now you have to give the claim. The insurance company will not give the claim. 10 crore rupees. 10 रुपये भी नहीं देता कोई किसी. स्कूल टीचर ही पढ़ाते हैं फ्री में. Nobody do anything in the free. Teachers are teaching. Even a small child who don't know ABCD also, he will come for a tuition. उसके मम्मी बोलेंगे सर एक सप्ताह पढ़ा के देखेंगे whether you can teach or not. चाय की दुकान पे जाके बोले एक चाय पिला के देखो पी सकते हैं कि नहीं. Nobody does. Anyway, that is a different issue. उस पर तो हम घंटों बात कर सकते हैं. तो वो क्या 10 crore rupees देना है. The insurance company will not give 10 crore rupees. Insurance company will say let us have the DNA fingerprinting. So all the bodies which are there, some of the cells are there, they will be taken and their chromosomes will be separated and they will be passing through all these cells and this thing will be taken. And now you match it with that person's blood group is not there. So you have to match it with their children. So if it matches with one of the child, then one has to accept. Not Narayan Tiwari, ex-chief minister of UP or Haryana, I don't know. One man comes and says, he is my biological father. He says, I don't know you. The lady says, this is so-and-so person is your son. And then the court ordered the DNA fingerprinting. And he has to accept. So there are so many cases where the DNA fingerprinting is used for solving cases. Okay, so that's all for today, and my chapter is over. Now you have to read the chapter and find the problems. If there is any, then you can come tomorrow, ask me in the doubt class. Else we will start new chapter, and there will be a test in the coming days. Thank you, children.